Hey, good morning. Let me know if you can hear me. Check. It should be good. All right. Yeah, let's get started. Once called you. It's a Monday morning. Actually, if you made it to today's stream, I'm then at one. Thank you. Thank you so much. All right. So we'll get started. I want to keep you. So I'll just jump right into it. Think we should be good now. So we are reviewing, still reviewing this book, Software Craftmanship. If you were here last time, remember we went up to chapter 3. The aim was to finish the book, but the book has 19 chapters, and we just did chapter 3. But today I decided to change the format a little bit to put it in form of slides, and perhaps that we can move fast. And also let me know whenever I'm getting off track. But soon I'll be having a producer. I just actually got a producer who we are onboarding. Will be much better. I think the producer will be telling me whenever I'm off track, and they're also telling me about the timekeeping and all that. So, but anyway, welcome. So we did basically what we did last time was part 1. Let me go back here. So we covered mostly of this part 1, but we didn't finish part 1. It was, I think, 4 chapters. So today I'll just be picking up from the remaining chapter. But if you missed it, I'll link the video of what we discussed last time. I'll link the video here on the description, so you can be able to catch it. Huh? So my approach basically is I'll be sharing just highlights from the book and giving a little bit of my commentary, like some, maybe I've only just found one part that I think I didn't agree with the book 100%. So just maybe amending places where, like, yeah, I feel that. So that's what I'll be doing mostly. I feel like that for me, that's a better approach. It takes time, as opposed to just me jumping and telling you about the book high level and tell you the chapters and then we finish there. I would like that even from this review, you can say, okay, I've maybe read the books by second hand. Anyway, so we did part 1, tackled all these parts here. I'll just go to the place when we were concluding that discussion on chapter 3 before you jump to chapter 4. Yes, so I'll just come here, finding more application metaphor than software engineering. So this book was basically, the first part was laying the foundation for now to define what software craftsmanship is all about. And one of the things that the author says that even the Software Engineering Institute realizes this fact, as can be seen in the title of an article written by Watts Humphrey. Why don't they practice what they preach? So this basically was the shortcomings of software engineering, that it's good on paper but hard to implement. And then software engineering was created to solve the problems of really large groups working on multi-year projects. Remember the Safeguard project? Most modern software development, however, is done in relatively small teams. I totally agree. If software has to be done at all, actually, even. Yeah, so, and then, but then feel free to, I'll be looking at the chat. So I have my chat here. So I have 2 screens. Don't be afraid to put your comments. I'll be able to see them. If you have any question, any additional stuff, I like it to be interactive. We throw in your also what you think, your ideas. I love that. So this changes. So chapter four, that's what we didn't cover last time. So starting off from chapter four, moving on. So ops, and I'm sorry, I didn't tell you what how we are going today. I noticed I fly the plane without telling you where we are going. So this book has five parts. I won't finish the five parts today. So today I'm going to do mainly part two. These I'm just completing on the part one, part two, and part three. And then the last installment, I thought this would be the last, but look, doing the slides, I was getting to slide number 70 thereabout. I felt it might be good not to rush through, so I'll try and finish these parts two and three today, and then we'll do part four and five. So this is what I'm talking about. Let me just go back real quick. So if you're just joining me, so this is the part I'll be covering today. And then this hopefully the final session. So today won't be the final session. I thought it would, but uh, uh, it won't. So the last session we covered part one, but partly we didn't finish part one up to chapter three. So that's what we'll be looking at today. So let me just go back to where we were. So chapter four. Okay, these changes mean that we need to start paying a lot more attention to the collaborative, intellectual aspects of software development. Because the engineering that I remember was just paying attention to the processes and not even caring about the people. It's like you have to do this and that and that. Design first, requirement gathering, design, and all that kind of thing. But not even thinking about the person doing that stuff. And we notice that the person is actually at the center of everything. That's what makes the project either move or fall apart. So the stereotype of the loner or cowboy programmer is slowly changing. As developers realize that they have to collaborate to produce really great software. I think you guys can totally agree, who on the call, that collaboration is key. Like doing you can do it alone. You might actually do it faster sometimes, or depending on the scope of the project, but it won't be as good as when you have been collaborative efforts because of those just diversity of approaches and ideas, especially if you have a very good team. So managerial solutions have been introduced, giving us very detailed methodologies for organizing developers, but providing very little guidance on how to do the task. So by forcing developers to communicate they are building, about the system they're building, extreme programming is recreating a craft studio where everyone learns from each other. So this was the time when extreme programming was being introduced also as an answer to the pitfalls of software engineering. And so in many ways, extreme programming has rekindled the debate about whether software development is science, engineering, or art. Guys, on the call, what do you think? Just put on the chat. Like, do you think engineering is a science? Is it an art? Is it an software development? Because if I say software engineering, already I've classified it. What do you think? So, a recurring theme among software developers has been the idea that software development is really a craft. Although this idea has been underrepresented in in books, but outliers are the programmatic programmer. I think we mentioned this book that this is like the contemporary time. This book was also written during that time of pragmatic programmer, very another classic. But maybe one day we should also review it. If you love to come and review it, actually, you're welcome. The practice of programming and the craft of software testing being notable exceptions. The concept really resonates with developers. Similarly, Paul and all that it goes on to other things. Just talking about introducing this idea of software craftsmanship, and then what? So this is like context about this is This was like a feedback, like one of the guys in the team that were building this thing called Gossamer Condo. So at one point, McCready mentioned how the blueprints for the Gossamer Condo, I don't know if that was the pronunciation, were created after the team had won the Kramer Prize. The Smithsonian Institute wanted detailed engineering drawings, and the McCready talked about how long it took to create the drawing for one part that they had just bent to fit. What design drawings they had were scratched in the dust on the ground because they got paid for flying a figure eight, not drawing blueprints. This idea really resonated with the developers who much prefer to write the software rather than write the design. Okay, so this one I wanted to send a rebuttal, and I think even Zeo here will the Wakazi here will agree with me. But don't pass the judgment early first. So the book is not saying that craftsmanship is all about not following engineering aspect of things, like maybe design first approach. Still, there's a place for design. And actually, there's a very good place to make sure that you follow a design first approach. You get even feedback quickly from a design before you can go into implementation. So, but there's the engineering. So where these authors coming from? The engineering side had put design almost at the supreme end of everything. Like folks will iterate on design on month over month, just going back and forth on design before they can go to building. Which you see now, it's another extreme. So I think all these things you have to take them in sort of a spectrum. Like, do you design first? Do you code first? Or just jump right in? I don't know. So I think it's a spectrum, and you have to have that balance. Of course, coding first is bad. Designing first, like maybe that's not the right word to use. Design first or design only or whatever. Like going hard, very hard on design, like month over month, just iterating on design before even you try out the actual code. Most people have seen is like even as they're designing, they're trying to prototype to see okay, will this design work? So they try to do a prototype to just check and test the design. So basically, they're doing an iterative process of design code and maybe not deploy really, but back to design code, just to see how everything will fit together. Yeah, guys, I told you about not having a producer. You see, I'm still saying we are starting at 7 a.m. So good. So then let me go back to the comment side. I'll be able to see if you say anything there. My credit talk was inspirational for developers because it pointed out that creating an evolving design that can be tested is more effective than trying to create the perfect design on the drawing board. So this is like just following the trail of what the author was saying. I see software development as a creative blend of art, science, and engineering, whose purpose is to deliver effective systems. The software craftsmanship metaphor allows developers to acknowledge all aspects of their craft, the artistic, the and aesthetic aspects, as well as the measurable and mechanical aspects. Yeah. So that's basically the essence of software craftsmanship. Initially, blacksmiths had to do everything for themselves relatively quickly. However, the extraction and smelting of iron ore were handled by other people, as was the making of the charcoal, so specializations. During the prehistory of software, programmers were initially involved with the development of the hardware, but very quickly the hardware engineering and the system engineer programming fields diverged from the field of application development. Initially, everything was being done like almost like full stack. Okay, now part two. Now that I was just trying to warm you up to that idea of what is software craftsmanship. Now part two is dealing now of like what really is software craftsmanship. So let's go. A key failing of the software engineering metaphor is that it fails to place people at the center of software development process. I think we've said this over and over. Over the years, trying to get people out of the software development process, none of the attempts has really worked. The old dreams of natural language specification. Now this one hit me actually. I think, guys, you might see some parallels here. The old dreams of natural language specification being read by computers, then that then automatically create your software are just that, dreams. So uh, this one is coming very close to, now we're talking of GPT and all these LLMs and all that kind of stuff, where people can just give a prompt. Now, let me call it prompt engineering. That's what the name is. So this is still a debate that is up there in the wild. Do you guys think? I'd like to hear your takes. I'll really love to hear, especially from there. Do you think like this prompt engineering? What is your view on this prompt engineering? And because this is also the time early 2000, folks were also grappling with these ideas of, there were some dreams of the computers doing the coding themselves and all that. So I'd like to hear if you have my views, but let me hear from on the chat, like what you think. By that time they said they were dreams. I don't know if they are still dreams anymore. So let's see. We do not have any tools that let us bridge the gap between requirements and design. Skilled developers are the only way to do it effectively. So I guess here the word in bold should be skilled. Okay. At one time, the hardware was the most expensive part of our system, but now the cost of developing the software exceeds that the cost of the hardware. This is the new reality of software development. People are the most expensive resource. Parallel, so this again still that idea of there's been still those ideas of replacing the programmer, trying to say like, can we do away with the programmer and just automate this thing? So the old times they used to have a tool called CASE, computer aided software engineering, like where this CASE tools or toolkit will help you, like from design you can easily generate code or like this code generators and all that. So parallel came repeated attempts to define computer-aided software engineering tools, CASE, CSE, that will do away with the need for hordes of programmers. Both of these approaches failed. So this is where now I'm saying prompt engineering and all this kind of stuff. Do you think at some point folks will have to start working with very lean teams of engineering where if you're an average engineer, you easily be sort of retrenched and they can just work with a few good engineers who can use prompt engineering plus their, because the machines can do some of the work and then you need to supervise whether it has done the right thing also as the senior engineer or the whatever the lead engineer on that team. So we might have a team of 2 engineers and 3 bot engineers. I'm just thinking, maybe someone is still already cooking up such a thing. What was missed in this effort was the real craft of software development and all the programming law that had built up during the 1960s and 70s. Yeah. Oh, but also on this, I just wanted to say that software craftsmanship is the answer to that view that programmers can be replaced by these machines which do we can do the stuff, because I don't think the machines will do up to some extent, but those finer details, the what Japheth was calling test aesthetics, I think test is variant and it just comes with every person has got their own test and all that aesthetics of software engineering or development. So I think software craftsmanship might just be the answer to this debate. The vision that CASE tools will eventually eliminate the need for programmers also turned out to be a myth, because it turns out that writing the code is no longer the hardest part of software development. The reason that large projects report productivity in the range of 10 to 100 lines of code per developer week is not that developers are slow at writing code, but rather that it takes a lot of time to figure out what to write. I think you can attest to that, folks. Craftsmanship is about getting better at software development. I think we've also talked about this, like just bettering yourself as a software development. That's all about craftsmanship. So craftsmanship is about gaining mastery. Yes, a person can learn to perform a subset of the tasks in a relatively short time, but developing complete mastery does not happen quickly. A related idea is that one practices a craft and that as soon as a person stops practicing, her mastery fades. Hence, beginners are apprenticed to a craft because people cannot afford to take time away from their craft to teach others. So there was that battle between like you stop maybe coding, you go to teach folks, and then maybe sort of like a boot camp, and then go back to coding. So the author was just saying that that approach of separating the learning and the core and the development is not good because that sometimes when you're teaching, so the person teaching might be also losing some of the skill that they had. So it's just better to continue with the software development cycle and then let people learn from you together. So you are learning, so it's sort of intertwined. Learning is really part of the software development. So I think that's how the author is looking at it. But of course, in the nitty gritties, you can always split up like days, like a day of learning or half afternoon of learning and stuff like that. But this, I think, was thinking in terms of you taking a whole long break to go teach other people the craft. In traditional crafts, the apprenticeship is situated learning, where the apprentice takes over the easy, mundane tasks and then absorbs through observation and supervised practice the tacit knowledge necessary to perform the more historic arcane tasks. Each apprentice trains a successor so that he can move on to more advanced tasks. In this manner, the master craftsman has to be concerned only with the teaching the most advanced skills and can focus attention on productive work. So basically, just that hierarchy of someone not feeling that they are wasting their time to teach. So it's like apprenticeship. It still has also levels. You have the apprentice doing the mundane tasks, and maybe even here, let me just spin off to just say that to just give my advice. Like if you're looking for mentors or if you're looking to get into open source projects, this is how you start. It's open source can be the best actually place to be apprenticed because you're sort of working with these folks without really working with them. Like they're not your co-workers, but you actually you sort of they're rubbing some nice things of you. So things like you can go to a project. The first thing you can do is to observe the project and see where are they lacking, or where is the maintainer spending most of the times doing the mundane tasks, like maybe this and that, and just offer up. DM the maintainer and ask them, can I help you with this stuff so that you can focus on these other things like code reviews and all that, and I could help you with organizing that. And while you're there, you're still observing and learning from. You're looking at the code reviews. You're looking at this, so you're learning about the project. So through that, you're already getting mentorship from this maintainer or this master, quote unquote, and then you're now growing up in that apprenticeship ladder. So that's a very good way of if you're out there and you're wondering like how do I start on open source, don't think about opening the first pull request like as a way of starting. You can start off with mundane tasks, and it's a sort of quid pro, like where the you give so much to the maintainer until they feel like, oh, I think I'm overusing this person. Where whenever you ask any help, or like, let's hop on a call. You can help me with. I want to do this new PR. Could you help me with just some guidelines? Because they already know you. You've helped them a lot on the other mundane tasks. They can easily help you with their time. So, in contrast, the craft world expects everyone to adapt the process to quit his own unique abilities and talents. What matters is the outcome, not the process by which it was achieved. So, software craftsmanship makes us consider the people doing software development. What makes exceptional developers exceptional? What does the mastery of software development look like? What lessons can we learn from the experienced developer? So, like, you see, the developer is really at the center, at the core of all this. And then it goes on to mention some of the books, like in the 1970s and early 80s, a wealth of books that attempted to capture the experience of knowledge of working programmers was published. Examples include early works of Gerald Welbeck, PL/I programming, a manual of style, the psychology of computer programming. This book I've heard about it. Someone recommended it. I haven't read it. Henry Legard's Programming Proverbs. I haven't also heard about that book. John Bentley's Programming Past. That's on my list this year. So those like the books that were early books that were attempting to look at both sides of the coin of software development. This practice of capturing tradition has been revived with the reassuring of many classic books like Programming Pearls and the Psychology of Computer Programming. Indeed, Hunt and Thomas, with their book, The Pragmatic Programmer, have brought these ideas up to date. All these books focus on the people who do software development and their attitudes and skills. The pragmatic programmer says it best: programming is a craft. So, a call to arms. So this is actually the end of this part one. It ends with this section where just sort of like it's calling a call to arms. This book is a call to arms. We must insist that developers really know their craft before we trust them to create systems for us or with us. Whether you are a user, manager, or developer, it doesn't make sense to trust an inexperienced software developer. This is why we focus on software craftsmanship rather than software engineering. The best processes in the world will not save a project from failure if the people involved do not have the necessary skills to execute the process. Conversely, really good developers can make any process work. Yeah, so though I just want to qualify this part, I hope you understand that trust in experienced developers. I think here it's just saying that you shouldn't put like a bunch of everyone is an experience, they're just flying in the dark. Basically, the author is trying to insist on the idea of it has to be fully pure craftsmanship. You have folks who are really good and they're mentoring the inexperienced folks in the craft so that you're building with that wholesome team together. Yeah, software craftsmanship is about uh, getting the job done. Craftsmen build their reputation based on the quality of what they deliver to their customers, not on the process they use or the ways in which they market themselves. So claims that good developers can pass the certification exams are made, but the hidden implication that passing the exam means you are good a good developer is really the classical problem of confusing correlation and causality. The fact that a developer has passed a certification exam says nothing about that person's ability to develop a useful application, only that she has learned how to pass the exam. So this is like a sort of an exclamation on certifications. So of course there are even people who have tried to. I think I didn't. I think let's go. I think there's a place you'll hear about SCM, Association of Computing Machinery. They also said that there's no way you can do certifications. So software craftsmanship is different. When one developer recommends another developer, he is putting his own reputation on the line. This scenario is whole a lot different than an organization saying that this developer passed the certification exam. The certifying organization has nothing at stake. So you're just saying that when you certify, they'll have an indemnity like saying this is as much as we tested this person. But if someone else, like another software craftsman, uh, recommends another person, you can trust that more because they're putting also their reputation in line. So the answer may be a more diplomatic. So this is the context of this is you're asking when you're asking for referrals of a good developer, like maybe you're looking for a good developer. that, hey, tell me which good developer do you know that you can recommend? I'm starting this project. The author was saying that the answer may be a more diplomatic, like I don't know enough about the developer's work to comment either way, but that is it itself enough information on which to base a decision. So, like, depending on how that person says, like, okay, I recommend Nanda, but I'm not really, can't say I've worked with him. So already that's caveat already says a lot. Yeah. One problem that the ACM saw, yeah, this is what I was talking about, the about certification and ACM. One problem that the ACM saw was ongoing, the rapid evolution of the field of software development. And I think it's still evolving, like even up to now. As much it is hard to define a useful body of knowledge that covers the necessary ground, but will not do anything useful to assure quality and safety. So ACM said ACM's position is that our state of knowledge and practice in software engineering is too immature to warrant licensing. Moreover, the council felt licensing will be ineffective in providing assurances that about software quality and reliability. Like that time governments wanted, or even up to now, there are still many people want that short circuit. Like, yes, I want someone else to give me a trust, their word that this thing is gonna be good. So people are saying, no, 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 I cannot tell you that this will be. It's more complex than that. So just because this was done by certified software engineers, if that was gonna be the thing, does not really mean that the software is already of high quality and reliability. So the quality officer for a safety critical system project will shut down development. So that is like way back when doing, like, you remember the challenge and all those things that happened, disasters that happened for software earlier on. So they had to put now QA officers, uh, but uh, but the author says that that can work for the those large projects. We just have money to actually make sure that we have people QAing this every aspect of that has been built. But now when it comes to just general software, but no equivalent person in applications development has the authority or power to stop a project for shoddy work. Because even you won't tell if it's really shoddy work. So uh, so these just are contracts. For example, cars typically have fewer than 1,500 parts and fewer than 5,000 unique part numbers. By comparison, this book contains about 50,000 words, and the Space Shuttle software contained approximately 420 lines of code. Now, this is even just this is just like peanuts now when it comes to, like, if you go check. I want to check the numbers for example, the Linux OS code base. I think we should be doing at least more than millions. I think it should be in millions. Let me just say in millions. But I confirm, if you can Google for me quickly and just tell me how many lines of code does the Linux kernel have. You can see in software the problems are even harder, even with multiple reviews and copy editing. Most books contain a few typos or mistakes. Now imagine the problem that a licensed software engineer will face when asked to sign off on a space shuttle software. Like, sign off on this one saying that you really can vouch for every line that was written here. The concept of a single responsible engineer signing off the complete work is not feasible for software. So the key problem is that licensing assumes that it is possible to inspect quality into a product. This approach is the wrong way to improve quality, and even the manufacturing world has shifted away from this concept. Yeah. So that's just like rebuttal on licensing. And lastly, I think or still on licensing, craftsmanship is a better option because you do not have to put in a lot of defects and then spend money removing them again. We can all benefit from the reducing a reduction in wasted time, money, and effort. So, and we are going to qualify that what that really means. So the problem of software development is abundance, not scarcity. So this is like about you can get you can easily get average developers that are like but getting good developers is hard. So just explaining in this paragraph that there is no shortage of people who can develop software. As anyone has ever placed an advertisement seeking a software developer will tell you, any marginally attractive job gets a flood of responses. There is an abundance of developers. We do, however, have a shortage of good developers with specific skill sets, and it is a lot of work to wade through all the applications. So, given that this is like 20 years ago, not 20 actually, even I keep saying 20, but this book is getting to 23 years now. So 20 years ago, this still is the case even up to now. So it means it's quite a stable field. Like that spectrum is very clear and still there. Like average developers and then good developers, they're there, and you can. It's hard to find the good ones. The idea of using certification or licensing to cut down on the number of applications to a manageable level is crazy. It simply encourages people to collect the appropriate bits of paper, consider the number of jobs for which a university degree is. Like, just giving that example of, you said, okay, you put a bar that everyone must have a university degree for you to get this job, and then now, before you know it, the market corrects itself. Everyone now is having a degree. Now you are out of and the things you can use to sieve off the people because many people are applying. Yeah. So let me check some comments here just about the certification. What do you? This is Enoch. Enoch, welcome. Just about the certifications, what do you have to say about them? I think this was before I think I read. I think you've had the okay. My stance is also close to what the author is saying, but I can say this. It is good to do the let the certification follow the craft. Like you maybe make sure that you're already good at the craft, and then certification is just a way of it's a key because it opens the doors because people are lazy. People who interview and people who are looking for developers, they're also inherently lazy. It is hard to really go look into someone, look at what they have been doing, look at their projects. So you need to build good signals that can easily, if I give you my resume, one page, it gives that person good signals that this person is the right person. So it gets you access to the room. So these are key. So look at the certification as the key. So whether it's university degree, those are just keys to open the door. But then now to help you get into the room. Because sometimes it might take you very long to get into some rooms because you don't have some paper. Yeah. But it's better to have the skill first and then let the papers follow. Even I'd rather like learn programming and everything and then go back to collect my university computer science degree or something. So according to clock run against the 3.2 or 3 or one thing or Linux kernel, okay, 12 million lines of code, as you saw, like 2000, they're talking about 420K being a lot of many lines, but now the Linux kernel, just the kernel alone, it's not like even the like Ubuntu or whichever of those distros has 12 million lines of code. Thank you, Enoch, for that plug. All right. Here, so fundamentally, though nothing has really changed, now all the applicants have degrees. Yeah, this is what I've just said. So we have to find another mechanism to filter them out. If a person became an apprentice to a great developer instead of studying for a degree, maybe the outcome would have been better. I think this time they were grappling with this idea like, will apprenticeship really work? But I think that was like 23 years ago. But now it has been proven like apprenticeship really works. If you get in the right place with the right folks, apprenticeship is the best. Because case in point, like we're talking of Andela, I used to be, I was among the first like guys, the trainers at Andela way back in around 2014. And we used to pick folks either straight from high school, others dropping out from uni. And most of them will say, whatever I learned in just the boot camp alone, 1 week or two, was it 1 week or 2 weeks of boot camp? I think it was 2 weeks, was more than whatever I learned in the whole of my 4 years in school. And then now when it comes to now the real program, now when you go into the apprenticeship program, and even it's now even skyrocketing, like the reviews. Yeah, so there's a way you can balance both. I don't think you can throw away the degree completely, but we are really need to pay good attention to apprenticeship. Now, part three. Let me see how I'm doing on time. Okay, good. I think I can finish part three. So that's today. We want to do part. If you joined us a little bit later, we're doing parts 2 and 3. So and then in the last installment, I'll do part 4 and 5. That's the last parts of the book. So the part 3 is now we've learned about software craftsmanship, what it's all about. All this, it's anti-certification. It's all about apprenticeship and all that stuff. I want to recap everything. And now part 3 is now what is the implications of software craftsmanship. So software craftsmanship is a metaphor that can radically transform the way we create and deliver software systems, and that has implications for the way we develop software, manage teams, and deliver value to users. After all, things rarely change just because of an idea. Instead, they change because we act on the idea and make decisions based on it. So basically, just calling folks now to, after you've learned about this stuff, it's good, it's a good idea, but now how can we implement it, put it to action? So you actually have to practice the skill under realistic conditions and under the watchful eye of an experienced practitioner who is providing feedback. In applying the apprenticeship model to becoming a craftsman, we can draw on the experiences and cultures of other crafts. By the way, this is another thing I wanted just to mention on apprenticeship. Oops. Okay. I had to mention something on apprenticeship that versus mentorship. I think I've mentioned it somewhere else in some interview I did. Apprenticeship versus mentorship. Mentorship is this, like you want me to be your mentor, like oh Nanda, I want you to be my mentor. So we'll be meeting maybe on call once, maybe a month, once in 2 weeks, and I'm that distance person. You see me like as maybe you put me at a very high pedestal, like wow, this guy knows this stuff, blah blah blah, right? So that's mentorship. Mentorship is like you are in awe of this person, and you're always just meeting. They give you some wisdom, and they go, they give you always all about like how can I help you today, and all that. Apprenticeship breaks down the barriers in a way that people don't know. Like I'm sure, like pick any developer that you love, like anyone that you think is really out of the park, like in the world. For me, for example, is someone like Linus Torvalds, right? I have some guys I work with on some open source project called Build Kit. Like you can see the stuff they're doing and just think like, wow, this is amazing stuff. But because of that distance, you won't really gain a lot. You'll gain only as much as you read or you meet them on a call, which is like a very short lived. But apprenticeship, you are with this person every day. You're right there with this person, and even some apprenticeship models like extreme programming, or I think it should be extreme programming or pair program, which uses also pair programming as one of the methodologies. You're working with this person side by side. The barriers will be broken. You'll notice like, oh, even this person does not know also this stuff. So it's all about mental now. It makes it easier to now think like, no, 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 I can close this gap. Yeah, I can be better. I can be better than them, or I can actually reach their level. But sometimes because of that gap of not knowing what goes in behind the scenes, you always have you're in awe of this person thinking like you can never attain those levels. So me, I always believe that you can attain any level that you like to attain. And if you meet most of these folks that you admire, you just notice that they're also human like you, and it was just all about time, the time they put in and all the work that they've put in. And this book also will be talking more about the work, putting in the work. So we need to be like blacksmiths, using the extra tools that engineering gives us and using the knowledge gained by science to supplement what we know from practice. Above all, we need to put pride back into software development. So this is just an introduction, just putting laying the grounds to make his cases. So craftsmanship is not a rejection of science and engineering, but rather a subtle blending of man, machine, and knowledge to create useful artifacts. I like that statement. Ultimately, it is about humans regaining control over the environment rather than machines dictating what is possible. Software developers share the human trait of liking to know that their work. Sorry, now I've gone to chapter 7, how craftsmanship affects the users of system. So software developers share the human traits of liking or knowing that their work is appreciated, that they are making a difference. And that is very true. You don't want to build something and you don't see the effect of what you've built. Like it's just thrown there in the dark. So this was like in the backdrop of software engineering where it was a long conveyor belt. It was following the industrial way of doing things. So you'll do your part, you hand over to another person. So you'll never actually get to see the fruits of your labor. And that is what really dignifies someone, dignifies your work when you see that your work is impacting life. And again, it gives people even more reasons to go on with this stuff. So without this kind of relatedness between developer and user, so it's just talking about that distance between developer and the user, that it needs to be a short distance. So without this kind of relatedness between developer and the and user, an unhealthy dynamic can arise in which communication between users and developers passes through intermediaries who act as gatekeepers and filter out the messages. So, like the companies that insist that even engineers rotate on being not just on call, like for managing the backend and the stuff, but they be on call for customer care. Like you actually getting, I think it was Amazon or something. They actually you get to see like what users are complaining about faster, not like through maybe a PM or something. So in small teams, that should be possible. So do you be able to see the raw feedback, not someone that has already filtered out. And that also gives you, you can actually feel your work. So maybe if someone is appreciating the thing that you did, and maybe you're just wondering whether people like this thing or not. And someone is saying, "Oh, but then I like the way you paid attention to this detail." You say, "Oh, guys are getting that, so let me do it a little bit more." Or sometimes when you get the feedback of maybe people are pissed about something you did, so you start knowing like, yeah, my implications are huge. So software craftsmanship works because software is easy to copy. So you're just uh, contrasting this with the industrial edge of building things like whether you're building cars and all that. That you cannot use those metaphors to explain software development. That this is is a bit different because like software is easy to copy, and this is what it's saying. In the mechanical engineering world, there are many economic arguments as to why craftsmanship is no longer feasible, primarily due to the cost of manufacturing the physical goods. So the problem I can then goes on and say, as noted in chapter 2, remember, good enough software is an application of software engineering ideas that trade off features, delivery, schedule, and quality. If you missed chapter section 1, we talked about the good enough software. Please go back to that. I think we had a very long discussion on good enough software. It would be nice to go and check it. And also, if you like, also in the book, you can just jump to chapter 2 and see that. Of course, the software developers are careful not to do this to themselves. Let's just talk about like quality. Why sometimes there are so many bugs in software, but somehow in some of the tools the software developers use, they are less buggy. So you're saying, of course, software developers are careful not to do this to themselves. Many programmers, text editors have remained virtually unchanged for more than 20 years. Things like think about Vim, Emacs, and all that. When new features are added, developers are careful not to break any existing features or change the file format. Clearly, developers do know how to craft software for many users. So they're just giving that rebuttal that you can actually have quality software. And then Alan Cooper, a visionary software author, is a strong advocate for users in the design of software. He also has a very interesting viewpoint on how to design mass market software. So he says this: to create a product that must satisfy a broad audience of users, logic will tell you to make it all as broad as its functionality as possible to accommodate the most people. Logic is wrong. We will have far greater success by signing, by designing for one single person. I want you to think about that. Like, if you think about this one single person, I think that people in product management have tried to, or UX, have tried to change this into like what they call personas. So you think about this one single person that you just say, I'm building for Nanda. What will Nanda want? And all that. He says that you have far better impact than trying to think about building for Kenyans or for Nairobians. If you want to achieve a product certification level of 50%, you cannot do it by making a large population 50% happy with your product. You can only accomplish it by singling out 50% of the people and striving to make them 100% happy. You see that? It goes further than that. You can create an even bigger success by targeting 10% of your market and working to make them 100% ecstatic. It might seem counterintuitive, but designing for a single user is the most effective way to satisfy a broad audience. So remember, we're talking about users and craftsmanship. Software craftsmen can use this idea to challenge the good enough software approach. Develop a close working relationship with a small number of users and then create the best possible application for these users. And somehow, other people will just join in. So, and then I also say that great software deserves to be signed. So these are very good. I think we're almost closing. If you have any comments or anything, I'm looking because we're almost getting to the end. I'll just stop right at 7:59 about. So, great software deserves to be signed. Software craftsmanship is all about putting the responsibility and pride. So it's both. So signing is a sign of first pride and also response. You're saying, call me anytime. Like, I'm the one who did this. I can stand by it. Okay. Software craftsmanship is all about putting responsibility and pride back into the software development process. As Hunt and Thomas state, this is in the pragmatic programmer, we need to start signing our work again, just as other craftsmen do. Signing our work creates a connection between the developer and the user. The user can see who created the software, blah, blah, blah. The other aspect is software craftsmanship says that we do not need to fake it. We can let people know who actually created the software. Indeed, many computer games roll the credits at the end, just as a movie does. So actually, this actually struck me. I'm not really a gamer, but gamers out there, you notice that at the end of the game, you have like the guys who wrote the code and all that, and you can tell like maybe there's something there. Like how many times do you get bugs in PS5 or you're playing FIFA and there's a bug? Like how many times do you catch those bugs? Like you can tell that there's a way the gaming industry also has a very high bar of uh, of quality because of the pride. Like if you say I'm the one who built FIFA 2024 or something, your name is right there. Like generations to come, they'll always be seeing your name there. So you start being a bit more careful and responsible. By signing our work as developers, we state our willingness to stand behind our creations and be held responsible for problems that arise in use. But that and it says yes, we might need some protection in place against outrageous claims for effects of mistakes, but that is very different from disclaiming responsibility and then charging the users when they ask questions or try to report a bug. So this is like just going against the idea of you build the software with bugs and then you have also customer support, which you have to pay premium to get customer support. You just get coming against that idea. but still there, I think somehow. Knowing that we are going to be standing behind our product forces us to pay attention to details. Developers gain respect as they build a reputation by delivering solid applications that work and by how they handle any mistakes that occur. So it's not like when you're signing, you're saying it's 100% perfect. You're saying, I'll be there. This idea is the basis of respect in all fields of endeavor. The knowledge that if a mistake is made, adults hold themselves accountable and responsible for the ensuring consequences. Users need to stop accepting. So you're just closing this and say, users need to stop accepting bad software. Good enough software sells because users are willing to use it. And chapter 8 now it goes to customers have a different relationship with the craftsmen. Just talking about the relationship between customers and the craftsmen. Customers who are paying developers to create software have to stop accepting rubbish. The old saying from Dijkstra, testing cannot prove the absence of bugs, can no longer be used as an excuse for not doing a good job. Theoretically, the statement is true. In practice, however, it is possible to come really close to that any remaining errors in the software do not affect operations of the system. Like the bugs that are there are implicit bugs, like even maybe bugs waiting to happen, but rather you've actually tested everything that it's working, the typical pieces are working correctly. Then software quality is another area that software craftsmen will push back on. So software quality, I think if you came to the review of the clean coder, we did also link it here on the chat on the description. If you came to the clean coder review, which was last week on Thursday, you heard about this, like about quality, and we discussed a little bit. So that clean coder also covers a lot about the quality aspect of software. And also this book goes in a lot on that. Say the problem is that the good, I have 1 minute to go. The problem is that the good enough software stems from the infection model of software errors. The idea that somehow bugs infect the software and that the cost of removing bugs increases as we eradicate the bugs. The idea is that it is possible to create feature-rich applications that are so valuable that the customer will forgive the mistakes that were made in creating it. You see, that's like what people pay the excuse. Like, remember there was a quote in the Good Enough Software chapter that I'll make you. I think something like I'll make you software with how many bugs that and you pay for it. Actually, you like it. But it has like 100 bugs or something. I don't remember the right quote there, but you can go check it out. Utter garbage. So you say that that's garbage. Bugs do not infect software in the way that calls infect people. Errors are made by developers as they design and develop the software. So it's not like it's not like they just creep in. Bugs are actually, of course, the word bug came from. Let me close on this. So the word bug came from the idea of. The first computer actually was actually a real bug. That's how the first computer happened. So, and that's how the word bug came about. But the bug is not really. The author is saying the bugs are created by developers, just like you and me. You know that they creeped in like the very first bug that happened in the first computer. It was actually a mole or a moth that got into the machines and caused the error. Yeah, so come to the top of the hour. I want to respect your time and let you go to work. It's Monday. If you made it to this one, more power to you. Like I just did it. I said people can watch it thereafter. This is the only time I could get something for the week to do this rather than pushing it over and over. So look out for the last installment that I'll be finishing on the remaining parts of chapter of sort of part 3. You can see this part, just a few. I think I got into this what we'll be going over in the next session, and then we'll close on part 4 and 5. So I thought I'll finish here, but you can see there's so many. There's no way I will have finished. So anyway, Thanks for coming. I'd like to hear comments even after the recording. What do you think about our discussion today and the book? But feel free to look for the book and grab it for yourself. It's an easy read. It's a book that you can read even while you're on a walk, or if you like listening to, maybe I don't know if there's an audio version of it. You can go check it out. Okay. So have a nice one and have a nice week ahead of you. And see you in the next one. And God bless you. Thank you.